So I think the decision to join the satellites competition was the love for the field that we're in, engineering, and I myself have taken previous satellites classes. Danny and I, we've taken satellites, orbital mechanics. And so I think that was something that we really liked doing, and we thought that it was a very challenging competition. So that was one of the reasons that we wanted to join.
Mm-hmm. Definitely for the learning experience, and more so for like the added challenge. Something that we learned a lot. Like we came into this, and I'll be honest, I was quite ignorant of like what it really took to make a satellite. I had taken a satellites class with Diego, and we did do like a final project, but nothing in depth as like what we did here. It was more of like just brush it off, kind of like a small satellite. This is more of like a mid-sized satellite that we made here, and definitely there's a lot that goes into it. The process is very random in the sense that you select something, but that thing affects the whole entire system, and you just keep on looping over and over again until the thing that you have is feasible or satisfactory.
I would have to say mainly communications, because I'm a mechanical engineer. I don't know anything about communications. I walked in completely blind, and surprised to say that I actually have some experience in it and know a little more than I thought I would have.
Yeah, it definitely opened up a huge field. For instance, like I was talking to Harris Corporation, I was able to have be able to talk about the communications aspect and their unfoldable antennas and gain and free space loss and all the different things that go into consideration into the link budget. So that was one of the biggest things, as well as other subsystems that went into the satellite that we didn't really know about. Thank God, for Mr. Ashford, and he helped us a lot along the way. He was incredibly knowledgeable, so that was a lot of help.
Yeah, his meetings were usually, do you guys think about this thing? Do you guys think about that thing? It's like, no, we kind of didn't. What are you talking about?
As soon as we think we have some sort of grip on it, there's like so many other things we have to start taking into consideration as well.
So definitely, I think the launch, we knew we were going to build somewhat of a medium-sized satellite, so between 900 and 2,000 pounds around there with fuel, so wet mass. So we obviously thought about a decent-sized launch vehicle, so that was one of the things we definitely took into consideration, as well as the amount of fuel we were going to take to get to Mars, since it is a long way transfer. We're doing a regular Hoffman transfer maneuver, though. You do have to take in consideration a lot of other things into the orbital mechanics in order to get an overall delta V calculation, as well as we need to also take in consideration the orbital station keeping that we were there, since the mission lifetime of the satellite was around 20 years. Alongside with that, we wanted to have a very high transfer bit rate, so we decided to go with a Ka band frequency, and I think that was one of the greater assumptions that I took as myself, but did you guys?
Yeah, there's like a bunch of assumptions. One of the things that we went for is cost effectiveness.
Well.
So our whole entire thing came out to be about $10 billion, which is not much for a Mars communication satellite. On top of that, the other thing that we did, so it was like some assumptions for cost effectiveness. The other thing is, like you said, the orbital mechanics, we basically assumed the lowest delta V's, very idealized, very non-real world. The real world was very random. Sometimes, accidents happen or certain things happen, and we definitely, we kind of overlooked that and said, okay, best conditions, how do we rendezvous with this planet with this certain
as well as reliability of the satellite itself. I think that was big too. We needed to make sure that all the subsystems that we were choosing did have extensive,
redundancies.
Yeah, redundancies for all the subsystems, and then we also needed to as well to have checked with the manufacturer if those subsystems would be able to, withstand the long period of time, because radiation was also an issue.
Mm-hmm. And one of the things Diego mentioned about the data rate, what we were really wanting to have is to be able to broadcast HD for when we have actual our astronauts land on Mars, what we want to be able to do is be able to broadcast that and send it to America, as like back when we landed on the moon. Everyone sat in front of their TVs and watched it and were amazed. We want to have that experience in HD this time when we first land on Mars.
Only it takes 20 minutes.
That's why we wanted to choose a higher data rate, because we would need that data rate to be able to transfer that huge file for the video.
Yeah, another assumption is we kind of deviated from like Lagrangian points in the sense that Lagrangian points are very cool, like from a physics standpoint, but they're very unstable in order to keep. You know, we kind of told our mentor, should we do this? He kind of deviated from that with reason. So, I mean, it's very cool, it's just, it's very unstable, and on top of that, there's a lot of debris, so there's a lot more chances for your spacecraft to get torn up in that debris field, and there's also a lot of dust, so the dust will cover the solar panels, which will, you know, reduce the mission life overall.
So, I believe, you know, the 20-year life expectancy that we were getting for the mission, I think that's about so, but maybe an extra 10 years. There is a lot of things that we need to also take into consideration as the biomedical kind of thing into the human being. You know, we're out there and you're gonna be traveling for such a long time. The radiation, that's going to affect it. Not only that, but once you land, you got to also be able to get back and, you know, launch back to Earth. And that, you know, depending on your orbital paths, it's going to take you longer on your way back than on your way there. So that's a huge thing, as well as the reliability of the spacecraft. What if something goes wrong? So I think that if we needed to get to Mars, everything has to be very concrete. Because you wouldn't necessarily want to, you know, broadcast this thing throughout, you know, the nation and having possibly, you know, your astronauts die on your mission, because then they would discourage, I guess, the space industry from accomplishing that and keep on moving forward.
Yeah, I also think that politics would probably have a lot to do with it too. Like, yeah, you got to take in consideration public opinion as well. Most people right now are like, why is my money going to space exploration when it can go to something else like, you know, healthcare or something like that? Whereas like back in the 60s when we were doing the space race, the big motivation was to beat Russia to get to the moon. We don't have that kind of, you know, drive right now. So we got to be able to influence public opinion and politics to be able to get this in the year. I mentioned I was doing mechanical engineering. I've actually didn't consider doing anything in space related. I was just mainly I joined this club for this project because I just joined the club and it was the only project available and it seemed interesting and I wanted to be able to contribute with these guys. But as of now, I mean, it's up in the air. I like the idea of working in the space field. Kennedy Space Center is right down the street from where we live, pretty much. But my opinion is, I mean, I'm still at a crossroad.
So I think definitely something within the space industry. I think that's definitely my passion. Satellites, I do have a passion for that. Just seeing something that you've built and then having been able to say like, yeah, I worked on that, that's in orbit, it's doing this, you know? Not only is it providing a beneficial kind of incentive to humanity, so I think that's really cool. Or like space launch systems, that's also something I really like, but I'm aerospace, so.
Daniel?
Yeah, sure. Ever since I was a kid, I mean, I went to Kennedy Space Center and I saw the rockets and I'm like, yeah, I definitely want to do something with space related. So as you grow up, you become more, I guess, knowledge. You expand on like what is out there and what really can do. So as of right now, I mean, my career path is very dynamic in the sense that I can either go into launch vehicles or satellite systems. Either way, I mean, they're both completely cool in their own respects. They have their own like nicks and things like that. But I definitely would like to work on like the complex problems that, you know, humanity has to try to achieve certain tasks to make, you know, eventually travel the stars.
So I'm a computer science major. I'm actually graduating this semester, so this is something that I probably should be thinking about. But yeah, at least within SEDS, and at least in our chapter, I'm one of the few computer science people. So all the projects that we've done, I've ended up doing a lot of the electronics and the programming. I have found that I've really liked working, especially after this project. I really enjoy satellites, and I've also worked on robotics projects. So I think I'd really like to just work, with robotics or satellites. Communications, not knowing anything about them going into this, it's really built up my, my knowledge of the subject, and it's exciting.